This is a video on trigonometry and the Pythagoras theorem, along with some of its applications. In this video, the fundamental principles of trigonometry will be explained and a few examples on the application of trigonometry shall be discussed. Firstly, what is trigonometry? Trigonometry is the set of theorems and formulas which involves the sides and the angles of triangles. Using trigonometry, mathematical problems involving triangles can be solved. Apart from pencil and paper problems, trigonometry can be used in all sorts of real-life problems such as navigation and crime solving. Before we move on, we shall look at the parts of the triangle, as shown in the diagram. Firstly, we have the adjacent side. It is called as such as it is adjacent or in contact with the reference angle. In a right-angled triangle, it is also known as the base. Secondly, we have the opposite side. It is also called as such as it is the side opposite the reference angle. It is also known as the height of the triangle. Thirdly, there is the hypotenuse. This is the line that completes the triangle. Lastly, we have the reference angle. This is the angle we are going to use in trigonometrical equations. It is often denoted by the Greek letter theta. We shall now move on to the Pythagoras theorem. Years ago, in ancient Greece, a man called Pythagoras found something amazing about right-angled triangles. If the triangle had a right angle, and squares were made on each side of the triangle, then the bigger square will have the same area as the other two squares added together. The equation is a square plus b square equals to c square. The following is an example of how the Pythagoras theorem is used. Next, we shall move on to trigonometric functions. Trigonometric functions are the relationships between the sides of a triangle with a particular angle. They are otherwise known as the sine, cosine, and tangent functions. Sine is equal to the opposite side over the hypotenuse. Cosine is equal to the adjacent side over the hypotenuse. Tangent is equal to the opposite side over the adjacent side. This slide shows a simple example on how trigonometric functions are used. Note that some problems could be applicable to more than one function. Now, we shall delve into the special rules of trigonometry. Namely, they are the area formula, the sine rule, and the cosine rule. We shall now look at the area formula. It allows us to find the area of a triangle when its height is unknown. Its general formula is half times b times c sine x. From this, the area of the triangle can be derived. However, the use of trigonometric functions alone are limited to right-angled triangles only. As a result, the sine rule was developed. It was found that any unknown side or angle of any triangle with at least two of the three sides and any one of these sides' adjacent angle known could be derived from the sine rule. The sine rule is as shown below. Sine A over A equals to sine B over B equals to sine C over C. Lastly, there is the cosine rule. This is another way to derive unknowns in a triangle. The given variables must be in the imposition of a condition of congruency, side angle side. Assuming it is the unknown, and the angle CAB, CMB is known, the equation is as follows: a square equals b square minus c square minus 2 times c times b cosine CAB. Here are two websites in which trigonometry is used in real-life situations. Both sites tells us that trigonometry are used in real life. The first website tells us of how trigonometry was used to solve a crime. The officials used the Pythagoras theorem to prove whether the suspect was committing a more serious offense than he already did. The second website tells us how trigonometry is used in surveying, in this case, to calculate the distance across the river. It uses the trigonometry function of tangent to find the distance. Here are the solutions to the two problems. Here is one problem we have decided to present. Every morning, you are to collect rubbish from two bins, bin A and bin B. Bin A is to be placed along the fence, and bin B is placed at a position 30 meters from the rubbish dump and 20 meters perpendicular from the fence as shown in the diagram. Starting from the rubbish dump, what is the shortest distance you have to travel to collect the rubbish from both bins and return to the rubbish dump? Looking at the diagram, the distance you need to travel is actually the perimeter of the triangle, RBA. Using trigonometry, we need to determine the shape of the triangle that gives the smallest perimeter possible by manipulating the angle RA and angle ISO. Step 1. Find hypotenuse of triangle RBA1. Step 2. Thus, find perimeter of triangle RBA1. Step 3. Using the value of RB and BA1, find angle RA. The calculations are as follows. Step 4. Find hypotenuse of triangle RBA2. Step 5. Thus, find perimeter of triangle RBA2. Step 6. Using the value of RB and BA1, find angle ISO. The calculations are as follows. In the two triangles, RBA2 had a lower perimeter, 80 meters, than RBA1, 86.1 meters. Since the two triangles represent the extremes of the infinite triangle configuration, there is no need to continue to test other triangles. Therefore, shortest distance needed to travel is 80 meters.